In this video, we will see some properties of the logarithmic functions, and we will see that they go one-to-one with properties of exponential functions. For example, we know that a to the n times a to the m is a to the n plus m. For example, we have 2 to the 4 times 2 to the 3. This is equal to 2 to the 4 plus 3. Let's see this. This is 2 to the 7, which is 128. And this is 16 times 2 to the 3 is 8. We can check that this is true. Actually, this is just 2 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. And this part is just 2 times 2 times 2 times 2 times 2 times 2 times 2. 2 to the 4 times 2 to the 3 is 2 to the 7. Very evident. And we will see that this goes with a property for a logarithmic function. This property will go with the property log in base a of x times y equal to log in base a of x plus log in base a of y. Let's see this. Let's call this x equal a to the n, a to the m, let's call it y, and let's call c equal to a to the m plus n. Then we have x is equal to a to the n. If we rewrite this in logarithmic form, we have that log in base a of x is n. This equation y equal a to the m. If we rewrite it in logarithmic form, we get that log in base a of y is m. And finally, c is a to the n plus m. If we rewrite it in logarithmic form, we get that log in base a of c is equal to m plus m. But now, let's see the property. This is log in base a of c. Notice that c is x times y, is equal to n plus m. But n is, this is n, and this is m, right? Then we have the log in base a of x times y is log in base a of x plus log in base a of y. And this property is essentially rewriting this property that we are very familiar with. In the same way, we can see how this property, a to the n over a to the m, which is a to the n minus m, it goes with this property. Log in base a of x over y is log in base a of x minus log in base a of y. And this property, a to the n to the m power of a power, is just the product, a to the product of the exponents. This property goes with log in base a of x to the n is n times log in base a of x. An important property that we have been using, for example, to compute log in base 2 of 5, if we only have a calculator that has natural log or log in base 10, we can compute this using that calculator. And the reason is the following. If we have log in base a of x equal y, let's call this, let's suppose that we want to find y. Then when we rewrite this, we have that a to the y is equal to x. But now let's apply natural log in both parts. Then when we apply natural log in both parts, we get natural log of a to the y equal natural log of x. But because of this property, the y, which is an exponent, goes down, and we get that y natural log of a is natural log of x. And when we divide by natural log of a in both parts, we get that y is natural log of x over natural log of a. Then if we want to compute this, for example, using the calculator, we will get natural log of 5 over natural log of 2. And in general, we have that y is natural log of x over natural log of a. We could have used, instead of natural log, we could have used log in base 10. And then we will have gotten the formula log in base 10 of x over log in base 10 of a. Then here we have some properties for the logarithmic function. Let's see how can we use those properties to rewrite some expressions. Let's suppose that we have log in base 3 of a square root of x squared minus 1 over y times x. Right? Suppose that we have that, and we want to write it as, we want to expand this as a linear combination of logs in base 3. Then we use this property, and then this will be log in base 3. The way to read this property is log in base a of numerator over denominator is equal to log in base a of the numerator minus log in base a of the denominator. Then here we have log in base 3 of the numerator, which is a square root of x squared minus 1 minus log in base 3 of the denominator, x times y. Now we realize that a square root of something is that something to the 1/2. Then we rewrite it, log in base 3 of x squared minus 1 to the 1/2 minus, and here we use this property. This is log in base 3 of x plus log in base 3 of y. Notice that the negative is in front, then I have to use a parenthesis. Now I use this property, and I get that this is 1/2 log in base 3 of x squared minus 1 minus log in base 3 of x minus log in base 3 of y. And this is how we write this log of a single thing as a linear combination of logs. This square root gives us this half, and it's positive because it's a numerator. This is part of the denominator, that's the reason of the two negatives. Let's do another example. We have something like 3 log in base 2 of x squared plus 1 minus 4 log in base 2 of x squared minus 3 log in base 2 of a square root of x. Then now let's write it as a single log. Then we start with this one here. These coefficients, we use this property, they go as power, right? Then here we have that this is log in base 2 of x squared plus 1 to the power of 3 minus log in base 2 of x to the 2 to the power of 4 minus log in base 2 of a square root of x to the power of 3. And here we could do these two first, and use this property. And then this is log in base 2 of x squared plus 1 to the 3 over x squared to the power of 4. But x squared to the power of 4 is the same as x to the 8th minus log in base 2 of x to the 1/2 to the power of 3. Now let's use this property. We have a difference, and then we can write it as log of a quotient. Before doing that, remember that if you have a over b and you divide it by c, then this is a over b over c over 1, and you do division of fractions by multiplying by the reciprocal. and then you multiply fractions by multiplying across. This is just a, b times c. Then to divide a fraction by something is just to multiply the denominator by that something. Then here, this would be log in base 2 of x squared plus 1 cubed over x to the 8th divided by this. But to divide by this is the same as multiply the denominator by that expression. Then we have x to the 8th times x to the, this is x to the 1/2 to the 3 is x to the 3/2. And then this is just log in base 2 of x squared plus 1 to the power of 3. And this is same base, then what is 8 plus 3/2? You add the exponents. And this is 16 plus 3 over 2. 19/2. This is x to the 19/2. Then this is how you write a linear combination of logs as a single log using these properties. Let's see how to solve one equation with using this property. If you have something like 3 times 2 to the 4x plus 7 equal to 18. Then we want to solve for the exponential part. Then we have 2 to the 4x plus 7 equal to 18 over 3, which is 6. And now that it's written like that, we can apply log in both parts, natural log. Then we have natural log of 2 to the 4x plus 7 equal natural log of 6. The reason is that applying natural log in both parts, this exponent will go down as a coefficient. And once this exponent that has the x is a coefficient, then we can handle it better to solve for x. Then we are using this property. This 4x plus 7 times natural log of 2 will be natural log of 6. Let's divide by natural log of 2. Then we have 4x plus 7 equal natural log of 6 over natural log of 2. And then 4x is natural log of 6 over natural log of 2 minus 7. And then when we divide by 4, we get that x is natural log of 6 over 4 times natural log of 2 minus 7 over 4, which we can get an estimate using the calculator.